So today, we're going to get into one of the most critical, but maybe less glamorous parts of brewing. We're talking about that short but intense journey of the hot, sweet liquid, the wort, from the boiling kettle over to the fermenter. It might not sound like much, but it's this high-stakes race against the clock, just packed with hidden dangers and some really ingenious solutions that can literally make or break a beer.
Right, so you've just spent, what, an hour, maybe more, boiling your wort, you've added your hops, you've developed all those incredible flavors and smells, the heat's done its job. But now what? The next 30 minutes or so are, and I'm not kidding here, probably just as important as the entire boil itself.
And it really, really is a race. Brewers have to clean this stuff up, cool it way down, and get this sugary liquid just right. They have to transform it from this hot, messy soup into a pristine, welcoming home for the billions of tiny yeast cells that are waiting to get to work. If you get this part wrong, well, you can pretty much kiss that whole batch goodbye.
Okay, let's dive right in. The very first major hurdle is that your perfectly boiled wort, it's full of, well, gunk. It's just all these unwanted leftovers from the process. And trust me, they have got to go.
This gunk actually has a name. It's called trub. Think of it as this messy combination of proteins from the malt that have all clumped together. Bits and pieces of leftover hops, some tannins from the grain husks, and even some fatty stuff called lipids. All of this is just floating around in there, and it is very bad news for your beer.
And as that wort starts to cool down, this cold trub starts to form. And if you look at what it's made of, it's pretty revealing. You see that? Over half of it is protein, and then another quarter is tannins. These two right here, they're basically the main villains of our story. Let's talk about why.
So why is this trub such a bad guy? Well, for starters, if all those proteins and tannins sneak their way into the final beer, they create this permanent haze. It just makes the beer look cloudy and kind of unfinished. Not exactly what you're looking for in a crisp, crystal clear lager, right? But honestly, it gets worse. Worse than how it looks is how it can end up tasting. Those lipids, the fatty stuff in the trub, they will oxidize over time, and that gives the beer this stale, papery, almost cardboard-like flavor. It's the classic sign of a beer that's gone bad, and it all starts right back here. Oh, and it doesn't stop there. Those exact same lipids, they are absolute assassins for your beer's foam. They just obliterate the surface tension that you need to build and hold a nice, thick head. So what you're left with is a flat, sad, lifeless-looking pint. Nobody wants that. And finally, all those solid bits of hop debris can literally smother the yeast. They can coat the yeast cells and block them from getting the nutrients they need to do their job properly. So it's pretty clear, right? All this trub has got to go.
So, how in the world do brewers get rid of all this stuff? Well, this brings us to what I like to call the Great Wort Cleanup. Way back in the day, brewers used these big open-air pans called coolships. And yeah, they worked, but leaving hot, sugary liquid just sitting out in the open, that's basically a dinner bell for any wild bacteria and yeast floating in the air. It's a huge infection risk. So today, almost everyone uses a much more clever and closed solution, the Whirlpool.
The physics of this are just so cool. The hot wort gets pumped into this big cylindrical tank from the side, which gets it spinning and creates a vortex. It's exactly like when you stir a cup of tea and all the tea leaves gather in the middle. This motion forces all the heavier, solid trub particles into this neat, tight cone right at the bottom center of the tank. Then the brewer can just drain the sparkling clear wort from an outlet on the side. Simple, but brilliant. Now, to make this whole thing even more efficient, brewers have a little secret weapon: kettle finings. A lot of times it's made from a seaweed derivative called carrageenan. And here's the magic. The finings have a negative electrical charge, and those pesky haze-forming proteins have a positive charge. You know what they say? Opposites attract. The finings basically act like a magnet, pulling all those tiny protein particles into bigger, heavier clumps that drop out way more easily in the whirlpool.
Okay, awesome. Our wort is now clean. But we have another huge problem. It is still dangerously, dangerously hot. Remember, yeast are living things. Pitching them into boiling wort would be like throwing them into a volcano. It would kill them instantly.
So we need to drop the temperature, and we need to do it fast. I'm talking about going from nearly boiling, around 97 degrees Celsius, all the way down to a nice, comfy fermentation temperature, like 15 degrees Celsius for an ale. That is a massive drop of over 80 degrees.
So how do you do that? Brewers use this incredibly efficient piece of gear called a plate heat exchanger. Just picture dozens of really thin corrugated steel plates all stacked together.
The hot wort flows through tiny gaps on one side of a plate, and cold water flows in the opposite direction on the other side. This creates a massive amount of surface area, allowing for a super fast transfer of heat from the wort straight into the water.
And you want to know the best part? It's pretty much a perfect energy loop. That cold water that goes in comes out the other side scorching hot, maybe 85 degrees Celsius. And brewers don't waste that hot water. They capture it and use it to start the next brew or for cleaning the brewery. It saves a mind-boggling amount of energy and money.
So here we are. Our wort is clean and it's cool. We're almost ready for the yeast. There's just one final and kind of counterintuitive step we need to take. We actually need to give the wort a breath of fresh air. Now, that might sound totally weird, right? Because fermentation is an anaerobic process. It happens without oxygen. So why on earth would we add it now? Well, before the yeast can even start making alcohol, it needs to multiply. And to build strong, healthy cell walls for all its new baby cells, it needs to create these key compounds, like sterols. And guess what? It can only do that if it has an initial supply of dissolved oxygen.
If you skip this initial oxygen boost, you're just asking for trouble. Your fermentation could get super sluggish or just stop completely, leaving you with a sweet, unfinished beer. The yeast itself will be unhealthy, which can lead to a whole bunch of nasty off flavors. It's a really bad scene.
Now, brewers usually add this oxygen in one of two ways. They can inject air into the wort while it's still hot, which is great because the heat sterilizes the air, but it can make the beer a little bit darker. The more common way today is to inject pure, sterile oxygen or sterile air into the cold wort. This doesn't affect the quality at all, but you do need some special equipment to make sure you're not introducing any contaminants along with it.
And with that, the race is finally over. That frantic, high-stakes trip from the kettle is done. We have successfully created the perfect home for our yeast.
Just stop and think about the transformation that just happened in a matter of minutes. We took this hot, messy, junk-filled liquid, we clarified it by getting rid of all that trub. We crash-cooled it down to the exact right temperature. And then we gave it a precise shot of oxygen to make sure fermentation gets off to a flying start.
So, the next time you're enjoying a pint of beer and you see how crystal clear it is, just remember that it didn't just happen. It's the end result of a violent boil followed by this super precise scientific journey of cleaning, cooling, and preparing. It's this invisible journey that makes sure what's in your glass is as close to perfect as it can be. Cheers to that!